Hi, I'm Naira. When it's time to focus, I get things done.
Hi, I'm Amira. Focus, responsible, always ready. I'll be moderating.
Hello, I'm Umaira, your reality checker, here to keep things realistic.
Hi, I'm Zafira. I focus on the details that make everything make sense.
Hi, I'm Shada. I break down the data and reveal the truth.
And yeah, this is us, a team of 5 with different personalities but one shared goal. Enjoy watching!
Students, hundreds of hours. One big question: how much time are Group5 students actually spending on their smartphone daily?
To answer that, we didn't just guess, we used mathematics. Specifically, we look at discrete data, which is numerical data that usually takes whole numbers, like this.
What is discrete data? Discrete data is a type of quantitative information that consists of distinct, separate values which can be counted, such as whole numbers.
How about whole numbers?
That is a good question. Whole numbers is a set of numbers including all natural numbers and zero. They are a part of real numbers that do not include fractions, decimals, or negative numbers.
But since we had 93 different answers, we couldn't just list them. We had to organize them into group data.
What is group data? Group data is a data formed by aggregating individual observation of a variable into groups.
Exactly. By using class intervals, we can turn a mountain of random numbers into a clear, readable data.
The table shows the result of a survey conducted using Google Forms among 93 K5 students. The survey collect data on their daily smartphone screen time. The response were grouped into hourly intervals, and the frequency column indicates the number of students within each time range.
Why does this matter?
These are sample screen time of K5 students. Nearly 7 hours are spent on the phone, mainly on social media apps.
Because excessive gadget usage affects everything, including our health, sleep quality, and even our grades.
Our project aims is to really think in our life, which is our daily screen time with mathematics. So let's see how the data was built.
Hi, I'm Zafira. I'll be presenting the structure of our group data and what each column represents. To start our data description, we build this group data table. This table is the engine of our project. First, midpoint or X represent the average value of each time interval. Second, frequency or F tell us how many students fall into each time bracket. And lastly, cumulative frequency, which helps us track the total number of students up to each class. This is very important when finding the median and quartiles.
And we didn't stop there.
What?
We also added 2 more columns, which is Fs and Fs squared.
Why did we have to add those?
Because those 2 columns are the keys to unlocking the mean and the standard deviation. Without them, we would just be guessing. Now let's begin with mean. Mean is average. The formula for group data is mean equal total Fx divided by total frequency. Based on the table, the total of Fx is 824 and total of F is 93. So after divided, we get 8.86. Therefore, the average screen time of a K5 student is 8.86 hours per day. Now mode. Mode is the most frequent value in a data set. We use the formula. From the table, the class interval 4 until 6 has the highest frequency, so it is a modal class. L is the lower boundary. From the table, L equal to 3 plus 4 over 2 is 3.5. Next, D1 is the difference between the frequency of the model class and the previous class. From the table, 27 minus 8 equal to 19. After that, we find D2, the difference between the frequency of the model class and the next class. From the table, 27 minus 25 equal to 2. Next, C or class width, upper boundary minus lower boundary. From the table, C equal to 6 plus 7 over 2 minus 4 plus 3 over 2. So, C equal to 3. After apply the mode formula, we get the most common screen time among the students is about 6.21 hours per day. Next, the middle value of the data or median. First, calculate n over 2. N is total frequency. From the table, n is 93. 93 over 2 equal to 46. This means median position is 46.5. Next, we look at the cumulative frequency column. The value 46.5 lies between 35 and 60. So, the median class is 7 until 9. Now, we use the median formula for group data, where L equal to 6.5 is a lower boundary of the median class. F capital equals to 35 is a cumulative frequency before the median class. F equal to 25 is frequency of the median class. C equal to 3 is class width. After substituting, the median is 7.88 hours. Now look at the quartile Q1, represent 25% of the data. To find its position, we use the formula Q1 equals to n divided by 4. N equals to 93. After divided, we get 23.25 value in the data set. 23.25 value fall inside the 4 to 6 hours, so this is the Q1 class. Now we apply the quartile formula for group data. Let me explain. L is the lower boundary of the class. CF is the cumulative frequency before the class. F is the frequency of the class and H is the class width. From the table, L is 3.5, CF is 8, F is 7, and H is 3. After substitute all, Q1 equals to 5.19 hours. Then we repeat the same process for Q2 and Q3, which represent 50% and 75% of the data. By using the formula n over 2 and 3 n over 4 to find their position and then applying the same quartile formula, so Q2 and Q3 equal to 7.88 and 11.33 hours. Next, we calculate the interquartile range or IQR. The IQR measures the split of the middle 50% of the data. We use formula Q3 minus Q1. Q3 is 11.33, meanwhile Q1 is 5.19. After calculate, the middle 50% of student screen time spend about 6.14 hours. Next, we calculate the standard deviation. In simple terms, standard deviation tells us how much student screen time differ from the average. If the value is small, most students have similar screen time. If the value is large, it means screen time varies a lot between students. Since our data is group data, we use standard deviation formula for group data. From the data description table, summation fx squared is 9766. Summation fx is 824. Summation f is 93. So the answer is 5.18 hours. Lastly, let's find the variance of the student screen time. Variance is a number that tells us how spread out the data is around the average. To find the variance, we just square the standard deviation. Variance equal to 5.18 squared equal to 26.83. This means the average squared difference from the mean screen time is about 26.83 hours squared.
So, what did we learn from our 93 K5 students?
In conclusions, our analysis shows that while screen time varies, most students spend about 7 to 9 hours a day on their gadgets.
This project shows that group discrete data isn't just a classroom exercise. It's a tool to analyze patterns and draw meaningful conclusions about our generation.
Math is everywhere, even behind your screen. Thanks for watching.
Bye! Specifically, isn't just a classroom exercise.
About 7 to 9